Alright, this video is going to be on our introductory section into our textbook, which is actually not a chapter at all. They title it Chapter P, but it's going to be on algebraic expressions and real numbers, basic operations that you've seen throughout your time in algebra class in general. So first, we've got to get a little bit of notation, because when you're doing math, you have to make sure that you're talking about the same things, whether you're communicating with someone in your classroom or you're communicating with someone across the world. So the good thing about math is we do use these common notations, these common ideas. Number sets, just a group of numbers. Generally, we'll talk about a group of numbers that maybe this is the solution to an equation, something along those lines. Some basic notation, we'll have the name of the set will be a capital letter. So the name of the set is capitalized. And then what we call elements of the set will generally be a lowercase letter. So we might use capital A to describe the set as a whole, but if I said 3 and 4 as elements, we would use a lowercase letter. Vocab to go along with sets would be union and intersection, and those words kind of have an intuitive meaning behind them as well. Union, you think about a union in general outside of the math setting, a gathering, a joining together of two different maybe people. We might talk about a marriage as a union. A union is a grouping of more than one set of numbers. A grouping of more than one set. So the notation for this would be generally a kind of a bolded U. So if I said A union B, I'd be talking about all the numbers, all the elements of both sets A and B. So in this case, we use this squiggly bracket to begin our set. Say these are what the elements that are in our set. Our A union B, would it be everything that's in A and B? So what do I see in A and B? Well, I see a 1, I see a 3, I see a 4, I see 5, 6, 7, and 8. Meaning that it's in those elements could be found in one of those two sets, either A or B. Notice 1 is repeated in both sets, 7 is repeated in both sets, but it's really unnecessary to list them more than once. Intersection, if you think about what is an intersection, well, here's your two streets meeting. What's the intersection? The intersection is in the middle here, where these two sets, or the two streets in this case, overlap. So intersection would be the overlap of more than one set. So if I had A, and the symbol we use for intersection is the opposite of union, it would be the U upside down. A intersected with B, you'd say, well, what elements appear in both A and B? Well, 1 is in both A and B, and 7 is both A and B. So the intersection of sets A and B would be 1 and 7. Using that knowledge, I'm going to leave you with these sets to complete. We already did A union B and A intersect B. So remember, A union B was 1, 3, 4, 5, 6, 7, 8. And A intersect B was 1 and 7. I'm going to leave you with the rest to do on your own, so you may want to pause the video here. The next portion of our chapter, our introduction, would be the idea of classifying real numbers. First off, as this large group here, real numbers, what's included in that? Almost any number you can think of, except for, hopefully you've had some experience with the number I. So I is not a real number, but that would be the only number that doesn't go into the category real numbers overall. So classifying real numbers means giving them a category, just like in science class where you classify different animals. We want to classify numbers as to what group they belong to. So classifying real numbers, when we talk about real numbers, we can break them up into two big groups. Those bigger groups are called rational numbers and irrational numbers. And I'll put a description with each of these. And also more notation. A real number, generally we write this kind of block R to represent it. Rational numbers, we use kind of this block Q to represent. Sorry to flip back there. My apologies, that's the bell for the middle school. The irrational set we represent with a block I. What's a rational number? Look at the word ratio. Ratio means fraction. Sorry, a little technical difficulty there, but irrational numbers would be this block I. Ratio means fraction. And how do we know if a number is a fraction? Well, if it's written as a fraction, that's pretty obvious. For instance, 2/3. But what else can be written as a fraction? Well, fractions can be written from numbers that are decimals that terminate, meaning they end. They have an end to them. So 0.765. Probably back in like 5th grade, you were writing that kind of number as a fraction. Decimals that terminate or decimals that repeat. So for instance, 2/3 that I just wrote is 0.6 repeating. As soon as you have a repeat for your decimal, that means it's going to be able to be written as a fraction, whether or not you know that fraction yourself. So all of these would be examples of rational numbers. Irrational would be the opposite, numbers you can't write as a fraction. Numbers that can't be written as a fraction would include, your classic examples would be something like pi. A number you're less familiar with but is also irrational would be the number e. The only other thing that exists as an irrational number that you're familiar with would be a square root of a number that is not a perfect square. In other words, a square root that does not come out evenly. So square root of 5, square root of 21, all of those are not perfect squares, so those are irrational numbers. That's the only category we have under irrational, but under rational we have a few more categories, smaller groups. We're getting smaller, smaller, smaller. The next smaller group we have under rational would be the integer group. Integers we represent with the letter Z, block letter Z, because of the root of the word in German. Integers, numbers on the number line, whole numbers that are numbers on the number line. So for instance, -2, -1, 0, 1, 2. So no decimals. Integers are positives and negatives that can be found listed on the number line. So up to infinity, down to negative infinity, all of those numbers. Below that group, and it might make more sense to view this chart building up, would be whole numbers. Whole numbers makes more sense. That's at block W. And then below that group, might make sense to do this last group first. The smallest group is called natural numbers. Natural numbers are the numbers you count with. Sometimes they're called counting numbers. So they include 1, 2, 3, everything you're going to count your way up with. Whole numbers includes all the natural numbers, but then sticks 0 in that group as well. So if we're going to categorize a number, we're going to put them into one of these groups, one or more of these groups. We maybe want to be more specific and say that a number is a natural number instead of listing it out just as a rational or as an integer or as a whole number when the most specific is natural. Natural, sorry I forgot the symbol, is an n, a block n. So kind of here's your visual for your chart. Rationals and irrationals are your two big groups. Natural numbers is a smaller group under rational. Whole numbers, whole numbers are a little bit bigger group. They include 0, and then integers includes all the whole numbers and then their negatives. So kind of give you an idea of the size of these groups. So which group do these numbers belong to? I'll do a couple of them here, and then I'm going to leave a couple for you. Square root of 3, what we said is this is the square root of not a perfect square. Square root of 3 does not work out evenly. If you use your calculator, you'd get a nice long decimal. That means this cannot be fraction, not be written as a fraction. So not a fraction, therefore the group that it belongs to is just irrational. So when categorizing, you might want to say to yourself, okay, is it rational or is it irrational? So if we look at the next example, to your right, 0. 0, is that rational or irrational? Well, can I write it as a fraction? Well, 0 over 1. So yes, is it a fraction? Sure. So it's rational. The next group I want to check, let's go with the smallest group. Is it a natural number? Do I count with it? No. So natural, it's not a natural number. Is it a whole number? Well, yeah. Whole number includes 0, 1, 2, 3, on and on and on. Is it the next biggest group would be an integer. If it's a whole number, it automatically has to be an integer. If you go back and look at that Venn diagram, it makes sense that a whole number would have to be an integer, would have to be rational. So we want all the categories that a number belongs to. I'm going to leave 3/4 and -6 for you to complete on your own. All the categories that those numbers belong to. We're going to end this video with simplifying some algebraic terms. So again, a little bit more vocabulary for you. This is a pretty vocabulary heavy section. But simplifying algebraic expressions, generally you all are used to just kind of executing, not really thinking about it. But terms are the individual pieces of the expression. I'm not going to go with like a super mathematical definition, but the individual pieces of the expression would be your terms. So what makes each individual piece different? So different variables make different terms, and also different powers of variables make different terms. So this example up here would have 4 separate terms. We have an x variable, a y variable, a z variable, and then a constant term. So that's 4 different terms. Coefficient is the number in front of a variable. A word that you've heard before, and it's going to be important to us as we go on to different things, for example, quadratics. Like terms are important to us because they have the same variable and power on them. We can only combine, when we're simplifying algebraic expressions, we can only combine like terms. So we are going to do one example quickly, and then I'll give you one to bring to class tomorrow. Just quickly, when we combine like terms, 3x and 7x would be 10x. I think you've seen this enough to know what 7y squared minus y squared would be, 6y squared. I'm going to leave you with this problem should be pretty simple, and we'll go over it in the morning.